we want to graph f of x equals x minus 3 times x plus 4 times x minus 7. You should pause and construct everything you know about this graph. Construct this graph in terms of everything you know at this point. You should have done that. Okay. What you know is that this graph will have zeros at x equals negative 4, at x equals 3, and at, now let's put it out here a little further, at x equals 7. So we have negative 4, 3, 7 on the x-axis. The y-intercepts, you plug in x equals 0, you get negative 3 times 4 times negative 7. Okay, negative 3 times 4 is negative 12. Negative 12 times negative 7 is 84. So we have a point up here on the y-axis at 84. Okay, all this is automatic. You easily find the y-intercept, and when the function is factored like this, you easily find the x-intercepts. Now we want to look at the behavior of the function. Where is it positive? Where is it negative? To the left of negative 4, take a point that's much further from the y-axis than negative 4. Negative 100 is a good one. If you put in negative 100 for x, all these numbers are going to be close to negative 100. Their product is going to be close to negative 1,000,000. So the graph is going to very rapidly decline to the left of negative 4. Between negative 4 and 3, the graph can't change sign because there are no zeros. No asymptotes either, no asymptotes in this function. So the graph is positive. From here to here. And then between 3 and 7, well, we can pick a number. If you pick the number 5, 5 minus 3 is positive, 5 plus 4 is positive, 5 minus 7 is negative, so we have two positives and a negative. So the function is negative between here and here. Now these vertical lines don't mean anything except they demark the regions where the function is negative, positive, or negative. Okay, then to the right of 7, there are no zeros to the right of 7, so the graph can't go through 0, so it has to have the same sign at every point beyond 7. And if we plug, let's say, 100 in, all these numbers will be pretty close to 100 when we multiply them together. 100 times 100 times 100 is 1,000,000, so we're going to get something close to 1,000,000. So we don't have to go very far that way before the graph is really high. So it's going to be positive, and it's going to get really big. Now we have to draw a graph that has these characteristics. Negative here and starting out from down pretty low, positive here going up really high, and passing through these points in turn. And that's easy to do. We just sketch a graph something like this. Okay, that would do it. Now, there's an additional thing we can find. All this we can find at the precalculus level. So we haven't really done anything that involves calculus. But now we're going to try to find the locations and the values of y, of the values of this function at these 2 points, at the maximum and minimum. We're knowing that at the maximum, the function levels off, and at the minimum, the function levels off for an instant. And at the maximum, function's increasing on the left, decreasing on the right. At the minimum, it's decreasing on the left, increasing on the right. Alternatively, or also, since the derivative here is positive but decreasing towards 0, and then it becomes negative and more negative, we see that the derivative is decreasing from here to here. At least in the neighborhood of this point, we know the derivative is decreasing. And here, we know that the derivative is negative, but less and less so until it approaches 0. A negative number approaching 0 is increasing. And then it becomes positive and increases faster and faster. So the slopes do that. The slopes the slopes are increasing in the neighborhood of this point. So what's that tell us? Tells us that the second derivative is increasing. Slopes are decreasing here, means the second derivative, slopes are increasing means the second derivative is positive. Okay, the derivative of the derivative is positive. If the derivative is increasing, the derivative of the derivative is positive, so the second derivative is positive if the slope is increasing. Second derivative is negative if the slope is decreasing, because the second derivative is the derivative of the derivative, the rate of change of the derivative. If the rate of change of the derivative is negative, that means the derivative is decreasing. Slopes represent the derivative, slopes are decreasing. Okay, so now we're beyond the precalculus level. And of course we know that what we're talking about is finding the relative max and min values for the function. And here we need calculus. So we're going to go ahead and apply the calculus.